Yeah, we are live, definitely. Okay,
Okay.
hello everyone. Welcome everyone. Welcome Gerard. So today we are here to the episode 6 of Java Maple Leaves, and we will bring stars from the Java ecosystem and tech community in Canada. Today I am joined by someone who's seen technology evolve over the past 2 decades, right? Senior software engineer, polyglot developer, and leader, my friend Gerard Tarcisius. Welcome.
Thank you. Thank you. Thank
Great. So
you
it's
for having me on your podcast. I'm excited to be here on Java Maple Leaves.
very nice. It's a pleasure to have you here, man. And I hope we have a good time.
Absolutely. Yeah, it'll be fun.
So, um, let's see if we have. Let me say hello in the chat and we can start. So, yeah, if you have a question, just send on the chat. We can talk about it during this time. Cool. My friend, why don't you start to introduce yourself, how your uh, career in tech began, how it was 25 years ago.
Yeah,
Around.
I mean, yes. Yeah, I mean, yeah, I'm going to be dating myself a little bit, but yeah, I entered computer engineering at the University of Waterloo in 1996, and then it was a co-op program, so it took 5 years, and I finished in 2001. And then I stuck around at Waterloo and did a master's as well in software engineering. Um, and that was a long time ago. And then, in that time span, even just through my time at Waterloo, I was involved in the software industry. I did co-ops at different companies, at Texas Instruments, at a at Microsoft, and other companies as well. So that was a really fun, formative time for me. As a young, as an older teenager and then young adult in my early 20s, just trying to figure out this space that was software engineering and trying to understand, what am I going to do with myself in this world, in the software world. But so yeah, I graduated out of my schooling at Waterloo, and then ended up working at a telecommunications company for a couple of years, and that was all Java as well. And then I kind of took a little bit of a hiatus from the software world and did some other things for a little bit, some nonprofit kind of work for a bit, and then I kind of came back into the software industry about 15 years ago, and jumped into a company that was making sort of a video search engine type thing. And from that experience, it was a I'd done Java before professionally for 2 years, and then I came in here and it was Python, .NET, kind of native, brew your own JavaScript framework type of place. Um, and yeah, so it was interesting. I think one of the things that I saw that you had written about me was that I'm a polyglot programmer. I don't know if I'll. It's a very, very high praise to call yourself a polyglot programmer, but in some ways, I do feel like I've been exposed to a lot of different languages and different ways of thinking. And so, that has been a really good part of my own kind of software development experience. Um, and then from there, from that company, I then moved to the current company that I'm in, that basically does electronic health record software for long-term care, post-acute, in the medical field, essentially. Again, so I'm not a clinician, I'm not a medical person in any way, but that's just the industry that I happen to be working in. And yeah, lots of fun. I've been there for now about 11, almost 12 years, I guess, 11 and a half years. And yeah, enjoy every minute of it. Enjoy the people I get to work with. We get to solve good problems and fun problems. And problems that we kind of see, really kind of impacting the way care is provided to long-term care residents. So that's a really great way, I think, as a software engineer to just be to feel like your skills are being used in really good ways. And so yeah, I'm pretty grateful for the privilege of being able to being able to work in that industry, for sure. Yeah. Oh, sorry, I can't hear you at all. Um, yeah, no, there's no voice.
Can you hear me now?
Yes, that's better.
Okay. Better than later. Yeah, I hope now it's better. I changed the to this headset.
Oh, okay.
So let's see how it was.
Okay. All right. So we'll just keep going. That's fun.
Now
You might, yeah, that's better. Do you have the noise cancellation on it now? I think it feels like it got a little better. Can
yeah,
you say something?
it's okay.
Yeah, perfect.
Okay.
Yeah, yeah.
So, man, I called you a polyglot because when I I first entered in your LinkedIn, I can see all the possible language programming language and frameworks listed. So
Yes, yes.
that is the first thing came to my mind.
Yeah, yeah, yeah.
That's why I call it a polyglot. I of
Well,
course
thank
I
you. Thank you
understood.
for that.
Yeah, no problem. I I know that that is impossible with someone know everything about every language,
Yeah,
but at least one experience or some experience with each language you have you uh, that is very good for some technical person because you can learn and experience different paradigms, different data structures,
yeah,
and different ways to solve different
absolutely.
problems or the same problem.
Yeah.
And that is really
And
nice. So
yeah,
congrats for that. Uh,
thanks. Yeah,
For
and it's a
example,
good, yeah. I was going to say it's a cool thing to just kind of work even let's say like a language. I mean Java and .NET are probably more similar in many ways, but or like C sharp. But if you're looking at something like Java versus Python, there's like in Java the way you think about the language is almost quite different than the way you think about Python. And Python has its what they call like the idiomatic Python, and things are supposed to be sort of very intuitive, and there should be like one obvious way to do a problem. Like they have some other guiding principles in these in a language like Python. And Java, it's a little different. Like Java, you can kind of do anything you want. There isn't just one way to solve it. You can write things in different ways. And obviously you can do the same thing in Python too, but it's designed to sort of more intuitively lead you to one way of doing certain things. So anyway, that's one thing that I've kind of noticed in my thing. But also, I haven't worked in Python in over 11 years now, so it's been a long time for me. But that's kind of what I remember about
yeah,
the Pythonic experience.
yeah, that is cool. That is a
Yeah,
very that is a great experience. So let me continue with this subject about your career,
yeah,
your experience. So, looking back over 20 years in tech,
yeah.
what were some of the biggest turning points in your career?
Wow. Yeah. I mean, that's a big question. Um, I mean, even I can talk probably in terms of like delivery timelines, and I can also talk about sort of architectural trends. So maybe I'll talk about both of those sort of. I'll talk about maybe delivery timelines as just an example. When I started in the company I'm in right now, you know, we were sort of, still a bit of a variation of the waterfall model of software development. So we were, I mean, you did have the idea of Scrum teams and things like that, but and sort of agile development was a bit of a buzzword, and you talked about it. But we were working on like a 3-month delivery timeline. So we worked for 3 months on stuff, and then everyone kind of stopped working for, I think, about 2 weeks or 2 or 3 weeks, something like that, and then not stopped working, but like the active development paused, and then they did some significant manual regression testing, and then they would deliver. And so this is what, when I first joined the company, that is what the timelines were like. There were 3 to 3.5 month timelines. Now, I'm on a cadence where we're basically delivering to our customers every 2 weeks, and multiple sort of services within the company. Probably, I want to say half a dozen to a dozen services being delivered every 2 weeks on a pretty predictable, consistent, deterministic pattern and cadence. So it's just that part has that part. When you talk about delivery timelines and how that has to change the way you think as an engineer. Because now your feedback loop, you're a lot closer to your customer than you were when you were doing things 3 months away. Because now something you release something and your customer might say, I don't like that. And you now have, if depending on the scope of the problem, you might only have 2 weeks to solve that problem right away and then get it to them. So it's definitely become a lot more customer centric, I think, as a that and chicken or the egg. Like there's the customer centricity. Customer centricity kind of drives sort of those better timelines, but then those better timelines also then cause you to be closer to the customer at the same time. So it's like it's a loop, and they kind of feed each other. Overall, it's probably good for our customers, at least, because I think we're able to give them the value they want on the timelines they want, and we're able to give them actually what they want, as opposed to maybe guessing what they want 3 to 4 months in advance and then hoping that 3 months from now they still want that. Now we're able to give them smaller things, iterate, think about, give them smaller features that have some value that they can play with and experiment with, and then give us feedback, and then we can say, okay, yeah, that's good. Okay, we'll give you the full thing. We'll give you more of that. So I think that's been a big shift for me in my experience in the industry, looking at the last 10 years, I would say, at least I think other companies have been on similar journeys and maybe on different timelines. Like, it's quite possible that where I am now, like other companies were already there 6 years ago, and maybe they do things, they've been able to get there faster. But just in my experience within the scope of my company where I work, that has been sort of my experience. Is we went from this sort of long timeline and cadence to this much shorter, accelerated cadence. It is also important to remember, I think, for engineers and for the leadership of engineering leadership, to not burn your engineers out when you're working on these, what they call sprints, right? Like you're going, it's a sprint. Every 2 weeks is a sprint, so you have to be careful not to sprint so much that your engineers get burnt out as well. And I think at the company I work at, they've done a really good job of that. I think they have been very respectful of that, and it's been, that's one of the reasons why I think I've been there for over 10 years, because I've enjoyed the people that I'm there with, and I've enjoyed the fact that we are able to work on sprints in a cadence that is maintainable, and that is actually livable. Like you can live in this cadence. It doesn't feel like it swallows you up completely. So I think that for me is a tremendous privilege to be able to work there, but also, just fun to fun to think of that. And then the other thing I wanted to also talk about, I guess, when I'm thinking over 10 years, um, what I've observed has been sort of the way in which our architecture has changed. We used to think, the old way of doing things was this idea of what they called monolith. You would build this big system and you just keep building this bigger system. The system just one repository and everything goes in there, and when you deploy it, you've got this giant deployable artifact that you plop out there on the cloud somewhere. And that was the way we deployed things. And now we're using this concept of microservice a lot. Everything is kind of decomposed down into smaller problems. You have tighter ownership, with teams, so you don't have to have like one kind of team feel like they'll do something and break everything, because a team can be responsible for their microservice, another team is responsible for their microservice, and you kind of talk to each other through contracts. And but also when you have these smaller services, it also becomes easier then to deploy every 2 weeks. It's a lot harder to take this big service and hope that you can deploy it every 2 weeks. Actually, my company is sort of a good case in point. That we've got one big service that we still have, and we deploy that every 5 weeks because it's just too hard to deploy that at a smaller cadence than that. And then all of our smaller microservices are deployed every 2 weeks because they're microservices, and there's still a lot of functionality that is in them, but they can be deployed every 2 weeks. And it's because they're smaller and you've got kind of tighter ownership with teams. You've got the ability to do that. So I think yeah, that's the those are probably some of the things that come to mind right away, at least in terms of the pattern that I've noticed in my time in this industry.
But those certainly are many changes for the past years. I also agree with you, and I passed for some experience with not using agile methods and using, and it was a big change it in how we build software. Cool. So moving a little bit further, what technical and non-technical skills do you believe helped you grow the most? Because I'm thinking about that because you are someone with 25 years of
Yeah,
experience
yeah,
around that,
yeah, around that.
and keeping doing technical job, but also growing in the way that you can help other developers, being a leader and like a mentor in your company, but keeping doing technical job. That is something could be something challenging for some people because we had this old way to think that in somehow in my career, some way in my career, I will have to decide between keep technical or go to manager,
Right.
something like that, right?
Yeah. So okay. So the question is, what technical skills and non-technical skills do I find to be the most important? Right.
Yeah,
Um, yeah. I mean, so before I talk about that, I think I just want to talk too about even with managers. I'm finding now, again, when I remember when I was a co-op student in the late '90s, and even as a young engineer in the early 2000s, my the consensus, at least it seemed to be back then, and I anecdotally, this is what I observed, is that people who became managers in that time did not want to be technical anymore, and so they tended to be very far from the technical side of things. They had great leadership skills and management skills and all of those things, but technically they were usually not the strongest. I am finding that that is not true anymore. I'm actually finding that managers these days, at least in the context in which I work, again, they are very strong technically. Like the requirement for managers to have still, like, be able to, they don't actively code, but to be able to read and understand code, and to be able to understand design principles and architectural principles, things like that, um, is it's still, I'm noticing that. I'm noticing that as a trend for sure. So I think, so. That said, whether you remain as an engineer, or in a very technical kind of role more, or in the manage as a manager, you will still need to be technical no matter what. As long as you're in the engineering umbrella, like if you move into the business side or whatever, then you're not going to be needing those skills as much. But I guess to go back to your question about the kinds of things that I think I have found technically and non-technically to be helpful. Okay, let me start technically. Like technically, my fundamentals, my foundations have been some of the uh, most important. And these days, even, I think I'm starting to realize that as I get older, I'm starting to realize how important they are. And what I mean is, like, just fundamental things like data structures, algorithms, you know, sort of, you know, how does the pipeline work, like sort of computer architectural principles. That So these kinds of courses that I took maybe like in second and third and fourth year, like when I was in university, at the time you take these courses, you don't think, oh, this is going to be really helpful, or if you did, maybe after about 2 years in the industry, you're like, nah, that I don't I that's completely gone. I'm realizing now that that is so far from the truth. Like, it's what is real and what is true is that those kinds of skills to have a deep understanding of how software systems work, of how algorithms work, of how to measure performance, of how to estimate performance, to do things like big O analysis, complexity analysis. To do those things is so fundamental. And and in a sort of humorous kind of way, the way in which I try to explain this sometimes if I'm talking to people is that it's a little bit like doing, when you're working out, you don't just do biceps and triceps and whatever. You work on your core. Your core is like the powerhouse of your ability to do any physical work. If your core is strong, then you can do other things. You can do good biceps and curl, whatever. You can do all those other things. But if your core is weak, you won't be able to do these other things very well. And I find that we don't think about our core a lot physically, but our core is what enables us to do most of what we do in life. And in the same way, sometimes we don't think about our fundamentals and our foundational stuff as much, like mentally, but that strong fundamental foundational kind of understanding of software systems, math, is what enables me to be a good engineer today still. It's what kind of, I think, keeps me competitive. It's not sufficient, obviously. That's not all you need, but it is necessary. Like, it's something that you have to have, in order to, I think, be a good engineer, to be able to understand things deeply. That's my sense. And maybe things might change and different people might have different opinions on that too. But that's, I don't look at my university experience, especially kind of the opportunities. There are some things that you learn, sort of some fundamentals that you don't learn in university, but you might learn later on. Like,
Hmm.
in when you're in university, you might learn in a database course, you might learn about ACID principles or something. But another fundamental sort of analogous to the ACID principle, but in the NoSQL world, would be something like the CAP theorem or something like that. But those kinds of things you don't really you when I was in university, it wasn't around. You couldn't even have learned it if you wanted to learn it, because it just wasn't even a thing. But it became a thing later, and then you kind of add that to your fundamental understanding of, oh, how do things actually work. Um,
Yeah, that
so
is interesting.
yeah,
Sorry to interrupt you
yeah,
because
yeah.
this have a very good connection with a question we received
Okay.
from also a friend of mine, Ja Patrick, and he he sent exactly the a question that is I will post here.
Sure.
Let
Let's see it.
me and I will
Oh,
show the question here. So, how to know where to find knowledge and keep yourself updated with new tendencies and technologies in IT. How to internalize those technologies, like your example about NoSQL in the past when you made college, to really learn them if you don't use them at your work.
oh wow. Okay. This is a fantastic question. It's a loaded question. Honestly, I don't know that I can give you a comprehensive answer. I can give you a response to the best of my ability. Uh, but yeah, it's
Do your
impossible
best.
to answer this fully. But yeah, what a wonderful question for sure. Um, I mean, here is what I find. Have good conversations with people. So I find that going into the office sometimes, we go into the office once a week, and we'll often, when we do that, we will have a meeting room and we'll hang out for a couple of hours with the team. Um, and this is not the only way to do it, but this has become a more natural way, and one way that I've learned. You start to pick people's brain. You start to kind of pick up ideas from people. Um, for a season, for a couple of years actually, in the teams that I was associated with, we did something called a book club, and so we read. I think it was Clean Code, uh, and every week or every 2 weeks we would read a chapter of Clean Code. A bunch of us, maybe 6, 10 of us, and then we would come and then talk about it, and we would just kind of critique each other's ideas, and we just did a lot of like iron sharpening iron, like, hey, like, you think that? No, I don't think that. I think that's different. And we would just use the book as a basis for working through this. And Clean Code was very appropriate in that moment for us, because um that we are in the business of writing code. We're in the business of having to do code reviews, multiple times a week on people's code. So, like, for us to all have the same understanding of what we are looking for, even like, this is what it means to write clean code. But and the thing with the clean code idea is that it's the book is called Clean Code, but when you get into it, like, clean code is really clean design and clean thinking. That's kind of what it comes down to. So you're actually kind of going past the clean code. Maybe it's the thing that is the title that sells the book, but what it's actually cultivating in you is good, clean design and clean thinking. It's fine tuning your ability to think about problems. So that's another thing that comes to mind, I think, for me. Uh, I, I
Yeah.
I do follow a couple of people just on LinkedIn, and there, again, sometimes LinkedIn is a little bit of a fire hose. Like, it's just there's way too much information, and it can be a little overwhelming. So I don't live on LinkedIn. I don't go there, daily or anything like that. But like, if I go there, let's say once or twice a week, sometimes there's one particular channel that I visit. It's called Byte Go. And this is a guy who used to be I think, an ex Google employee, or a fan company. I think it was Google. Um, and he has this amazing system design tutorials and little crib sheets that he publishes. And I just kind of read some of those to get a sense of what's what people are talking about, even in the world right now, in industry. um, he kind of walks people through, like, how to design things. Like, he might walk someone through, like, hey, here's how Netflix designs its systems or something, and he will give you like a one-page thing, very high level, of how Netflix designs its streaming service. Things like that. That's another thing. uh, new tendencies and technologies in IT. So some of the things I'm talking about are actually more foundational and fundamental kind of things, and that tends to be where I tend to be. What I find actually in my life is that often it's the younger, the well, it's a combination of two things that I find pushing me to learn about the new trends and technologies in IT. Um, One is just business cases that come up and push against what we need to do, and that forces us to be to innovate. So we had to come up with a system a few years ago to do something called multi-tenancy. And it's not a problem that's unique to our company by any means, but we had some unique constraints around how we had to do multi-tenancy. And then this drove us, and I got to work on a lot of this stuff too, but this drove us to really explore how to find the right multi-tenant libraries, how to design a system that would enable us to solve our specific multi-tenant needs and multi-tenant problems. So this was something that like the business needs sometimes can actually push us to explore and look for things. I find often the sort of the younger generation of engineers also are a great way for me to expose myself to like cool ways of doing things. Like like in the AI world, for instance, there are people who are running their own LLMs on their computers. I still haven't run an LLM on my computer. I'm sure I could probably get it figured out in half an hour or an hour, but like I'm not super. I just haven't had time or whatever to necessarily sit with that and download it and figure it out. But there are people at my company, they're 25 years old and they're running their own LLMs on their computer, their own models and all of that, and that's great. Like, so I find sometimes young people kind of bring like a certain energy and a certain way of seeing the world that I really appreciate, because they're like pushing me to think, oh, okay, that's something that is also doable. Like I hadn't thought about doing that myself. But
Yeah.
the part of the problem is that not the only thing, but like there are so many things that you can try as well. Like I find that there's so many things you can try, it's hard to know which ones to try. You kind of have to pick and choose. um yeah,
Okay.
you kind of pick and choose your battles, like where you want to grow. And if you already have like a full-time job and you've got sort of other life commitments and things like that, like your time is often going to be limited. Like so you have to kind of say, okay, maybe I've got 2 hours. Depending on your, or maybe you got 4 hours. Like you don't have 15 hours probably. Most people probably wouldn't, but like whatever time you've got, you want to think about how do you maximize that. What one phrase that I learned at my previous company, so probably about 12, 13 years ago, was someone was talking about how people start their own companies, and they said they scratch their own itch. So like you, what is the thing that bugs you, and try to, if it bugs you enough that you want to solve a problem and you want to solve that specific technical problem, there's a good chance that it might bug other people too, and you might be able to make some money from it. This is sort of in the problem solving, like in the business starting sense. But even if you aren't wanting to start your own business, if you're just looking to learn, if you're thinking, what bugs me, how can I solve that, you will, and as you start putting your hands to it and writing a software application or whatever to solve that problem that bugs you, you will end up learning things, and you will end up pushing the limits of what you don't know, and then in the process you will end up having to go and do research and find ways to do things, and maybe as you're experimenting with Copilot or ChatGPT or whatever, like all these different sort of IDEs, Cursor, Claude, like if you're experimenting, they will also bring ideas in that you haven't thought about already, and you'll have an opportunity to kind of put all that together and see what it's doing for you, and figure out how to think about that too, and how to think differently about the problem that you may have had, and then how to learn some new things that it might throw at you that you might have thought, oh, I never thought I could use that library for that or that technique. And it, as you're experimenting and playing around, you might you
Yeah,
might stuff. Yeah.
yeah, and that is interesting because uh, it seems, from my experience also, that you usually you learn what is to you learn technology tools to solve the problems where you are in the context you are,
Yes.
or depend on the client or the product you are uh,
Yeah.
uh, working right now.
Yeah.
Because we, as you said, we have a lot of things, new technologies, new problems coming every day.
Yeah.
So it will depends,
Hmm.
and you also, as you said, you can create a product to solve any specific problem, and
Yeah.
then use what you wanna learn.
Yeah.
So
And
sometimes
yeah.
do reverse that is kind of hard
Yes.
to, because you will figure out a problem to use this technology or this tool. So
Yes. Another thing that just came to mind. So at the company that I work at, like last week, they actually gave the engineers an opportunity and said, "Hey, here's a week, and we will dedicate this week to having a company-wide hackathon."
cool.
So that's another thing that, if you're looking to, like, hey, how do I learn what's happening out there? How do I internalize new ideas or new technologies and pick up these things? We didn't talk about the internalized question, but I'll come back to that, I guess. But I want to talk about hackathons as an opportunity. Like, if you can find, hackathons that are going on, again, depending on your own life stage and the kind of, opportunities and time that you have. If you have an opportunity to do something like that, what a hackathon normally allows you to do is to experiment with things that you wouldn't normally experiment with. So it's a little out of your normal 9 to 5 kind of job, and you're playing with other things. It could be completely new technology or new languages or new frameworks or new architecture things, new cloud, all of those things you could do in a hackathon. So again, I think that's a great way to learn, to keep yourself fresh, to pick up new things that are going on, um, and yeah, to stay sharp. And you just have a week, and it's sort of a time box period of time, but you can kind of attack a problem for a week and learn as much as you can, and then you just kind of move on. Or I've heard of the traditional hackathon. I think is often like a weekend, right? Like that's the more traditional one that I've seen too. So you've got like a full weekend and people don't sleep for 3 days and they come up with something amazing. I've never done one of those, but maybe one day I will. I don't know, but I have a family and I have young children, so 3 days of no sleep feels like what I do anyway every day. So
Yeah, I completely understand you. Cool.
yeah.
So l- let's back a little bit, uh, because we were we spoke about this podcast some weeks ago,
Mhm.
and we also have to you. I'm certain you have something to share about no technical skills to grow that is important. Uh, Things that is not hard skills but are
Yeah.
soft, that involve people, involve my change and this certain of things. You can share a little bit how it was for you, or how you are seeing the markets during these years.
Yeah. Yeah. I mean, good question. I think, yeah, things are changing, underfoot, right? Under us in pretty significant ways, especially with AI. I think the software industry is probably one of the most easily potentially one of the most easily disruptable fields with AI, because you can use AI to generate software artifacts far better than you can use it to generate hardware artifacts or something. So and there's so much open source code and things like that out there that every problem seems like it can be solved. So yeah, so there's a lot of disruption on the one hand. I just kind of setting the stage there, and I think um, as engineers, I think as we navigate this, you know, the, our soft skills, I think our attitudes are going to be a crucial part of how we end up, fitting in and navigating and working in this new world as well. So, I think just in general, like just being curious is a really good thing. Just really asking questions about why things are the way they are, or why they work the way they work. Um, you know, I mean, as a kid, I got in trouble for asking questions a lot, and I think because that sort of the culture I was coming from, sometimes if you ask too many questions, it can seem a little disrespectful, and all of that kind of stuff. But some of those things, like I joke around sometimes, and when some of my kids are not doing the best from a behavior perspective, I kind of joke around and say sometimes maybe not being the best behaved kid is a good skill for being a good engineer later on in life, because it means that you're willing to push your boundaries, you're willing to try some different things, you're willing to like not just toe the line and
Yeah.
stay on the well beaten path. You're willing to get in trouble, and sometimes when kids get in trouble, as parents we don't always like it, but like as an engineer, sometimes you have to be curious enough to be willing to be able to get in trouble a little bit, and try things a little differently. Yeah, so I think just being curious, asking questions, being willing to kind of, and then I think taking ownership, for what, like not just kind of waiting for someone to give you a piece of work and then do that work, because more and more, if that is what you do, then you'll probably be easily replaced by either someone or something, AI, or someone who knows how to use AI. But I, instead of just that, like I think to be willing to say, look, I will take ownership and I will take initiative, and I will own this, like this is mine, and I'm not going to wait for marching orders. I'm going to take the initiative and start moving, and then ask questions. So go to this stakeholder there, or my manager here, or whoever over there, and say, hey, I'm starting to work on this. This thing is a problem that needs to be solved. How do we do this? Or how do we allocate time for this? Maybe they might say, okay, this is something we can't do right now, but it's a good idea. Let's park it and let's pick it up in 6 weeks or 2 months or whatever it might be. But that process, I think, of having the soft skills to be willing to ask questions is big, and take initiative.
Yeah.
I think another uh, another thing I think for me is also just learning that as an engineer, you actually have a lot to learn, and you will always have a lot to learn. Like, and so to have, I think I've found to have a posture of humility. Like there are junior engineers. Like I'm a senior engineer on my team, but there are junior engineers that I have worked with who know so much more about certain things than I know, and as an engineer, like I cannot be threatened by that. I have to be able to say, hey, that's great that they know so much, and let's just learn from each other. Like you teach me and I'll teach you what I know. And I think when you work in a collaborative environment where you're both willing to teach each other, then you're both going to help each other grow, you know and I think that's going to be an important part of being a good engineer, is like, can you work in a team, and can you, and also humility is also being willing to say, like, when I write a piece of code, to be able to take comments on the code review that come back to me, and says, actually, this was not the right way to do it. Like, there's a different way to do it that could be better, or something along those lines. and to be able to sit with that, to be able to accept that, and to critique it. Sometimes people might be wrong, whatever, but to be able to interact humbly with those ideas, and people come at you, to not take it personally, to not feel like, oh man, like they just attacked my very core of my being. No, it's just no, it's just a
Yeah.
hey, they just pointing out that there's something that could have been done differently, and it's okay. And you can also learn by doing things differently, and by learning from them. So that humility goes with sort of this openness to feedback. Like being open to what other people have to say to you. And I think all of this stuff in general, I think you can kind of encapsulate in like sort of a growth mindset. Like i am I am not, I don't have, I forget the exact opposite of growth mindset that's used in terminology. I think it's like static mindset or something like that. But like this idea that you're dynamic, that you can change, that you can become, as you interact with people, as you interact with ideas, as you um, put yourself in a position where you're willing to learn, that you can grow, that you have room to grow, right? Like we don't want to think as engineers that we have arrived, that if you're whatever, you're a senior or a principal or a staff engineer or distinguished engineer, like you don't want to think, oh, I have arrived. You want to think, oh, wherever I am, I can grow. I can keep getting better at my craft. And you know there's been sort of, in the past, there have been a lot of conversations, I guess, around people um, uh, talking about like this 10,000 hour rule. Like if you do something for 10,000 hours, you'll become really good at it. And I forget the exact, I think it was Simon Sizik or something like that,
Yeah.
the exact name, but he kind of pointed out that the 10,000 hour rule only works if you have coaching. Like it's not just doing something poorly for 10,000 hours. No, it's doing something for 10,000 hours with develop with intentional feedback built in there. So, and it doesn't always have to be a coach who is, older and better at it, because that may not always be feasible, but like to be even able to be peer coached, for people to be able to listen to people on either side of you and get their feedback and to learn from it. you know that's what's going to make that 10,000 hours uh, number, idea of getting better. That's what's going to make you get better. Not just doing the same thing on your own, without any feedback, but doing it with feedback and growing as you do it. So I think, like, those are some of the things that I kind of wanted to talk about, sort of from a soft skills perspective. I think those are the things that come to mind for me, at least.
Yeah. Perfect. Great, man. It was amazing your answer, because kind of link a lot of subjects in the same answer. That is pretty cool, and it was very clear for me. So now let me see. Yeah, let's talk about a little bit about the future and
Mm,
what you're thinking about your future. If you wanna share with us,
yeah.
like now with 25 years of experience, seeing a
Mhm.
lot, learning a lot, and also teaching a lot, what you are uh, what do you want for the next years? What you're planning, thinking, or what
Yeah.
else?
And good question. Thanks. Big question. You put me on the hot seat. Uh, I mean, I am I don't have major plans to kind of change sort of career direction drastically. I think I generally still want to be in the technology space, on the engineering side of technology. Um, uh, but I'm also of the mindset that I'm going to have to adopt and adapt to the world as it changes around me. So just from a like at a general level, even though speaking, let's say, just to make the difference really stark, 20 years ago, as an engineer, you're probably generating a lot of code, you're writing a lot of code, and even as you go up the seniority ladder from sort of junior, intermediate, senior, and then so on, staff, principal, and so on, like, but whatever it is, you're still writing a lot of code. You might do more design and architecture and things the further up you go, but you're writing a lot of code. What is happening now is that, with AI, it's actually disrupting our space quite a bit. So, with tools like GitHub Copilot and things like that, like, so much code is actually being generated for us. So, the role of a software engineer is already changing. In the middle of our current sort of moment in time and space and history, the role of the software engineer is changing. We're becoming, instead of just kind of being like code generators, we're becoming more like, these agentic, becoming more like orchestration agents, ourselves. Like, we orchestrate, we put stuff together, we create and put other AI agents to work together. We are maybe setting the parameters of an architecture and the parameters of a design, and then kind of focusing on the bigger picture blocks of things. We are going to have to, if AI and Copilot and tools like that are going to be doing a lot of the code, then as humans, we're going to have to do a lot of the code review. So the engineers' time spent is going to shift drastically towards more code review than code writing. And then we're also going to have to learn to be people who can understand, business requirements well, and be able to write requirements in ways that, large language models can understand and interpret those requirements, and then generate the code and generate the artifacts that need to be generated as a result of it. So, like, sort of those are sort of at least 4 areas that I'm seeing us significantly morphing our job over the next five years easily. Much more orchestration, much more architecture and design, much more code review, and much more kind of business oriented, translation of tasks from sort of customer want to machine understandable or natural language, LLM understandable concepts and work orders.
Yeah.
So that's going to happen, like, independent of me and my job and whatever my future is. That's just going to happen for all the software engineers out there. Like, everyone is going to be affected by that. So, um, in my world, for me personally, what does that look like? I mean, I think I have to adapt to that. I don't have a choice. I think to remain alive in the field, look, you have to learn how to do that well. Like, I've heard it said, and I think this is my intuition is about this, is that it's probably true, is that you will not be replaced by AI. You will be replaced by someone who knows how to use AI better than you do. Like, that's, and so it's just going to be, I don't like to talk about AI so much that it feels like I'm, stuffing it down anyone's throat, because I don't believe that that's the right posture to take towards it anyway. But I do think that we have to be realistic about the fact that it is an extremely powerful and capable tool, and we just have to know how to use it. Um, if we're going to be in this industry, I think that's just a part of our the world that we live in. So, for me, I don't know, like, because I don't know what other jobs. There might be certain kinds of jobs that exist today in the software world that might cease to exist, and then there will be other jobs that don't exist right now that might actually start existing in 5 years or in the next 5 years. And it will be interesting. Like, I remember a while ago, probably about 10 years ago, 10-15 years ago, there was like about 2 years ago, there was a really hot market for people who had the job title of a prompt engineer. It was just you could be hired as a prompt engineer, and it lasted, I don't know, 6 months or something, and then everyone had to be a prompt engineer. So there wasn't a
I
separate.
remember that.
Yeah, it was just like a little blip in the radar. But then there was a similar kind of thing. I forget, probably about 12, 13 years ago, and there was this thing called like a growth hacker. There was this job out there that was a growth hacker. Imagine sort of doing a hackathon all day. But like you're not going to be writing great code, but you're just trying to get stuff done really quickly to see if you can get stuff into customers' hands and get feedback really quickly. So this is what growth hacker was. In some ways, the growth hacker job has gone away. Like, at least to my knowledge, I don't see too many of that job title anymore. So I don't really know what happened to it. My sense is it's not there anymore, uh, at least significantly. But some of the ideas from it are actually the ideas that they wanted growth hackers to do have made their way into industry and into our field. So, like, you know, in many ways, all of us are mini growth hackers. Like, we're all, in a sense, trying to figure out how do we write something quickly to be able to put this in front of customers so that we can get their feedback and then immediately do something with it, or build on that, or change the tool, change the product so that
Yeah.
we can capture the market. So that's what I mean. Like, it's so interesting. I think we have to be willing um, to learn, to live with to almost with a certain ambiguity and uncertainty. Like, things are not very clear. What the next few years will look like. Um, but
Yeah, so it's kind of hard to make a major plan
yeah,
thinking in technical stuffs, right?
yeah, I think, yeah,
But I understood. I understood.
yeah,
Some we can remember a lot of things that is was impossible to think some years
yeah,
ago when we are doing today.
yeah,
So and we had to adapt the way we do things, right?
yeah, yeah, absolutely. Yeah, we had to adapt. And I think I would add too, like, when you're working with AI, because all of us in the software field are going to have to work with AI.
Yeah.
And here's something: AI is going to take over a lot of your fundamental thinking skills. AI will start to do more and more of. Like, you will not have to write your for loop anymore, your if statement anymore. You're not going to have to do those things because AI is going to do those things. You might have to think logically about it and say, look, I want you to loop through a bunch of items and do these actions, or I want you to do this, and if it is this, then do this, and if it is something else, like, you may have to give it some natural language if then statements and some natural language kind of loop statements. But
Yeah,
you're
yeah. And
you're not going to think about those things. And maybe just one thing I would want to add for engineers is, make sure that you don't forget to work on your fundamental engineering rigor, because here's I actually don't know the answer to this, and I don't know that I have seen a good answer from anyone in industry yet. And I've done a little bit of digging, trying, and conversations with people around this, and I haven't seen. But the big sort of open question for me is, or one of the big open questions with the way all of this is going to work itself out, Copilot, AI, all this stuff, is, if your job is going to change and you're going to be now one who's going to do more code review and less code writing. Well, there are two big questions that come up. One, how do you learn the domain if you don't write the code yourself? But two, how do you review code if you don't write code yourself? And I think that's going to be a big. I don't know the answer to that. I feel like people
yeah,
are not talking about it because it's almost uncomfortable to talk about
yeah.
it.
From my experience, in it's so much harder to read code from others than to write the code that you
Yeah,
want.
absolutely.
So that it will be a skill a lot of important for us to
Yeah.
read because AI will write or someone else will write, and you have
Yeah.
to review.
Yeah.
That will go to production. So
Yeah.
our skill to read and test that should be more and more calibrate, right?
Yeah. And that's true. Yeah. There's this. Yeah. Definitely. Like the calibration part is going to be part of it. But like, how do you? Yeah. I don't know. I don't know the answer to that question. Because I do feel like people will like. How do you know what good code is? How do you know what clean code is? How do I think Jian asked the question, like, how do you internalize these technologies? But you can generalize that. So, how do you internalize clean code? How do you internalize good code? How do you internalize good design? If you don't write it yourself, how do you internalize it? It's sort of like if you're learning a different language. I'm talking about human language. If you're Brazilian, if I'm trying to learn Portuguese, if I don't go and spend 5 years in Brazil or Portugal learning Portuguese, I will never be able to internalize anything. Like maybe I can get Google Translate to translate Portuguese to English for me,
Yeah.
and it will look like I know Portuguese because I can answer back because I got Google Translate to answer that, and then I got Google Translate to answer to translate my answer back to Portuguese for you. Like it could look like I know how to do these things, but in reality I don't, and I'm just trusting that Google Translate is doing a good job. So at some point we're going to just have to learn that well, at some point we're going to get to a point, if we're not careful, where we are going to trust that the system that's generating the code is doing a good enough job that we don't have to worry. But that actually is a little bit of my concern, is that LLM and code tools, by their fundamental definition, they are statistical averages. So they're just giving you the average of all the code that has ever been fed into them. They're not giving you the best code. They're not giving you the worst code. They're giving you the average code. So
Yeah.
I don't
Yeah.
know, you know,
That is hard. That is hard.
yeah,
We can we can let's talk. Let's do this question again in like 1 year,
yeah,
and do
exactly. I think that's
this
true.
episode in one
Yeah,
year or 2 years, and let's see what will be, right?
that's true. I think it
But
might be a good answer.
it's very philosophical, right?
Yes, I
What it
agree.
is.
I agree. It is
But
philosophical.
that is great, man. We have to finish, and
Absolutely.
we received a good night here from my brother Josias.
Oh, that was your brother. Okay, I did. I
That is
noticed the
my
same
brother.
last name. I was wondering if he was related to you, but I
Yeah,
didn't want to say
yeah,
anything while we were
my old
talking.
brother.
Okay,
And yeah, we have to close for today. It was an amazing conversation, my
great.
friend. I really thank you for your time, for your experience, your answers. I'm sure I learned a lot, and our audience also learned a lot. So for thank you also for everyone that watched or will watch us here on YouTube. And
Hmm.
if you have more questions to Gerard, please send to me. Send on direct in some, I don't know, LinkedIn, YouTube, or what else. And we can keep this conversation.
Absolutely. Hey, that was fun. Thanks for having me on.
Great. Thank you.
Thanks. Have a good